All right, we're going to cover the ideal gas law today. The ideal gas law is the one thing that's different about it. It looks at the amount of a gas, meaning the moles of gas. So what that equation looks like is PV equals N, which is your mole, number of moles. R is a constant, 0.0821, so you'll always plug in 0.0821 for R, and then T, temperature. Okay. Things to remember, again, this R number, 0.0821, that you got to remember that you plug that number in there. And temperature, same idea, you always have to add that, to put that to Kelvin. So if you have Celsius, add 273 to it. Okay, so let's look through the problem here. 3.5 moles, that's your N, of nitrous gas has a volume of 10.5 liters. That's the volume. The pressure is 3.2 atm. That's your P. What's the temperature going to be? So our temperatures are unknown value here. So let's plug in what we have. PV into PV equals nRT. So P, 2.3 atm. V, 10.5 liters, equals N moles, which is 3.5. R is a constant, 0.0821, and then our unknown temperature. Okay. All right, well, to get temperature by itself, right now it's being multiplied by 3.5 and 0.0821, so we want to do the opposite and cancel out 3.5 mole and 0.0821. And we're going to do that to the other side as well. 3.5 mole, divide by 0.0821. Okay, so your temperature, we're going to multiply 2.3 times 10.5, and then divide sign 3.5, divide sign 0.0821. Enter. So we get 84.0, and the temperature is automatically going to be in Kelvin. So when you work with the ideal gas law, your temperature, if you're solving for it, will automatically be in Kelvin. All right, let's do one more problem. Okay, so a sample of gas has a volume of 42 liters, pressure 10.2 atm, temperature is 300 K. How many moles do you have? So we're looking for an unknown amount of moles. Okay. So let's plug in our numbers. P, 10.2 atm, times V, 42 liters, is equal to N, our moles, which we don't know. We're going to figure that one out. R is our constant, 0.0821. And then the temperature they gave us is 300 Kelvin. Okay, so we want to solve for N, so using some algebra. Right now N's being multiplied by 0.0821 and 300. So we want to do the opposite. Divide by 0.0821 to cancel it out, and divide by 300. And we're going to do the same thing on the left side. 0.0821, divide by that, and divide by 300. So once it's all laid out, you can start plugging in your numbers. So we're going to multiply the top two numbers first. 10.2 times 42, and then divide sign 0.0821, divide sign 300. Enter. So you get 17.4, and then N is for mole, so we're going to label that mole. Okay, that's the ideal gas law.